Earthquakes. A natural result, a natural consequence of the fact that the Earth's crust moves around in plates leads to earthquakes. This is from 2 years ago. I haven't updated it. This was the earthquakes near BC over the 30 days before when I taught this 2 years ago. And you can see there are definitely more than one. There's a fair number. There's a fair number. We live in an earthquake zone. Not the worst, but certainly fairly high. We live in an earthquake zone. These ones are bigger than 6 on the Richter scale. We'll talk about how the Richter scale works. Certainly recently up here in what used to be the Queen Charlotte's, which is now called the Haida Gwaii, that has had some very big quakes in the past 5 and 6 years, 7s and 8s. Usually they've been out in the ocean, though, and far away from anything, so yay. So 2 years ago, magnitude 4 off of Haida Gwaii had occurred not very far from the village of Queen Charlotte. So what are some terms with earthquakes? These are all words that would be good vocabulary words to ask on your test, which is not that far away. The first is the focus. That would definitely be a good vocabulary word. What's the focus? It's the location where the earthquake starts, somewhere inside the Earth. Now, you may have thought that we call the location that the earthquake starts something else. You may have heard the term epicenter. That's actually the location on the Earth's surface right above the focus. So we talk about the epicenter of an earthquake, Alex. We're actually saying if you drew a straight line to the top of the surface of the Earth, that's the epicenter, but the focus, most earthquakes occur down below in the surface somewhere, down below the surface. Okay. Earthquakes can be shallow or deep. Which ones cause more damage? Shallow, because there's not as much rock to absorb the energy, which means they do more damage on the surface. So certainly vocabulary, I think the word focus and the word epicenter would be good words to ask. How do we measure earthquakes? We use the what scale? You've heard the term. Richter scale, named after a scientist whose last name was Richter. The Richter scale is somewhat controversial, and in fact, there's several different ways to measure the Richter scale. So everything that I'm teaching you right now is, Rachel, totally wrong, watered down, dumbed down, simplified, but it's close, okay? It's a scale based on powers of 10. What it does is it measures the intensity using what we call a seismometer. Come on, pen. There we go. That's why we call earthquakes seismic activity. And this part might explain to you why just a small increase in the Richter scale does so much more damage. A magnitude 6 is actually 10 times stronger than a 5. Each time you go up by 1 on the Richter scale, Julia, you're going up by a factor of 10. A magnitude 5 compared to a magnitude 3 is 100 times, not 20, 100 times. So magnitude 2s, for example, that's a magnitude 1.5 is about what you feel when a train goes by and you're parked near it, because you can feel the rumble through the air. That's about a 1.5. So a magnitude 2 is a little more than that. It's nothing. But the difference between a magnitude 7 and a magnitude 2, you're going to go 7, take away 2 in your head, which is what? It's going to be a 1 with 1, 2, 3, 4, 5 zeros. And that's why when you hear about a magnitude 8 or 9, those are huge. Huge. Theoretically, a magnitude 12, we think, might actually have enough energy to crack the Earth in half. Okay? Now, it's theoretical, because probably if it was that big, a lot of the energy would get absorbed and reabsorbed by smaller chunks and things, but at least on paper, in theory. So magnitude 2 can be felt. Yep.
The world theoretically were to split, I'm not saying like I'm sure what's happening or anything, it's just a theoretical question.
Well, first of all, I should also say, if you run the numbers for the energy required for that to occur, we don't believe there is the energy required for that to occur. But if you ask, how much energy would it take to crack the Earth in half, and what would that then require on the Richter scale? It's about a 12.6 or something. I looked it up years ago. I got to relook it up, but yeah.
But if the world, because I know this can't happen, but if it were to just like crack in half.
Yep.
And like.
By the way, I'm terrifying Courtney again. Yeah, keep going.
Probably. If it were to. Would like the atmosphere around the Earth stay, or would it just like crumble around it?
Probably if the Earth actually did crack, it has enough gravitational force that it would pull itself back together again very, very quickly, and the atmosphere is held on in by the Earth's gravity, so the gravity of the Earth, the mass of the Earth would not have changed, even if you had a crack running through it. And so the gravity of the Earth would not have changed. The atmosphere probably wouldn't make a big difference. It might try and rush in. I don't know. I'd have to think about it. Let me ponder. Magnitude 2 can be, yep.
What would it do to like the population?
Oh, it would be, you know, apocalyptic. It would be, you know, yeah. It wouldn't wipe out all humanity, but basically it would probably send us back to the caves and a population of a few 100,000 scattered all over the Earth and start over. Okay, that sounds like a good James Bond plot. A supervillain who wants to split the Earth and send us back because he's, you know, anti-industry. Anyways, magnitude 2 can be felt. Anything above around magnitude 6 does damage. That's enough to like start to crack bricks and buildings and things, and crack glass. So BC, by the way, I think you should know these terms. So here you should know the term subduction zone. That's where the oceanic plate is getting pushed underneath the continental plate because the oceanic plate is heavier. Again, that's very counterintuitive. People want to say, why is the oceanic plate heavier than the continents? The continents have all this land on them. The oceanic plate has land plus water on top of the land. Believe me, it's heavier. Here is your partial motion. You can see here's your volcanoes, continental crust, all that stuff. Did I give you that diagram? Yeah, I did. Okay. Seismic waves. There are 3 types of waves, and you're going to need to know this. You can make a little note here. This is on the test. It turns out. And Sage, now I'm going to answer part of your question. There are what are called primary waves, or P waves for short. And these travel through the Earth crust. They go through solids and liquids and gases. The ground compresses and stretches in the direction of travel. I'll give you a video and an illustration to help you realize that. They're the first to arrive. They travel at around 6 kilometers a second, which is pretty fast. Okay. If you have primary, what comes after primary? Okay, there's secondary waves, also called S waves. These also go through the crust. They go through solids, but not liquids. This is part of, Sage, how we figured out what's down below. Really big earthquakes, we can see where the secondary waves have not made it through, and we can then reason what type of substance must be in the area where they didn't make it through. So as much damage as earthquakes do, they're certainly good for researching what's down there because they're creating far bigger vibrations and waves than we could ever do manually. In them, the ground stretches and compresses perpendicularly to the direction of travel. Say what? I'm going to make it clear. The primary waves are the first to arrive. That's why they're called primary. The secondary waves are the second to arrive. That's why they're called secondary. They're also sometimes called shear waves. They do more damage, and you'll see why in a second. The last, sadly, they're not called last. They are called L waves, but they're not. L is not for last. L is for what all of you need a bit more in your life. They're love waves. It's a scientist named whose last name was Love, but you can remember that love waves are the last to arrive. Okay? And here's a little summary. Okay. Oh, and you can make a little note. Travel on the surface. The other two waves, P waves and S waves, can travel underneath the surface, underneath the ground. Love waves, L waves, travel along the Earth's surface. Give you a video of each, and I'll give you an illustration. I think show videos. Here are P waves. Oh, hang on, I gotta pause the video because I can't show a YouTube video on YouTube. So, earthquakes. You need to know P waves, S waves, and L waves. You need to know some of their characteristics, which ones go through liquid, which ones don't, which ones arrive first, which ones arrive second, and some more. I have a handout with some more details you'll get from the textbook. Volcanoes. Volcanoes. There are 3 types of volcanoes, and you'll need to know all 3. There are what are called, let's try that again. Composite, shield, and rift volcanoes. These are the big 3. Composite volcanoes, shield volcanoes, and rift volcanoes. What do you think a rift volcano looks like? What is a rift? A big crack in the earth. This is one that doesn't look like your standard volcano. It's a big crack in the earth from which lava flows. What do you think a shield volcano looks like? Take a guess. A shield. What is a composite? Let's start with the first one. A composite, this is your standard, what you think of as a volcano. It's cone-shaped. It would be neat if there was an easy way to remember that composites are cone-shaped. If I was clever, I'd have some dumb, easy way for you to remember that composite volcanoes are cone-shaped. Andrea, if I was a good teacher, I'm sure I'd come up with some way for you to remember that composites are cone-shaped. I suck. I got nothing. They are formed by very, very thick magma. And I should make a little note. Magma equals liquid rock. Below the Earth. Once magma gets to the Earth's surface, what do we call it? Yeah. Lava, liquid rock above the surface. Where do composite volcanoes occur? Mount Baker is a classic composite volcano. They occur at plate boundaries. Or just beside them. Remember the simulation I showed you at the beginning of class where we had the continental and the oceanic plate cracking? The volcano didn't appear right at the boundary. It occurred where the continental plate started to fracture just off the boundary. So Mount Baker is a composite volcano. They look something like this. Every time there's an eruption, every time that there's an eruption, you add an extra layer, an extra layer. Sometimes there's pipes that extend out and can get lava coming from the side instead of from the very, very top. And then generally at the top you have some kind of a crater. Composite volcano. Shield volcanoes. They're very large, but much flatter than composite volcanoes. It's a thinner magma, and so the eruptions are less violent because the pressure doesn't build up so much. These form over hot spots in the Earth's crust. Well, really, it forms over weak spots in the lithosphere. So these don't form on plate boundaries. So a shield volcano would be much flatter looking, not as steep, probably not as high, much wider. And it's often, instead of a violent eruption boom, it's often much more of a fairly continuous trickle. In fact, the Hawaiian Islands are shield volcanoes. And whoever was asking, you were asking about Yellowstone. Yellowstone is sitting on top of one huge shield volcano. Yep. Then there are rift volcanoes. These occur where magma erupts through long cracks in the lithosphere. Primarily spreading ridges. The Mid-Atlantic Ridge, Allison, where I told you that the Atlantic is being pushed apart, you have lots of underwater rift volcanoes there. So mostly, because most of the spreading rifts are underwater. Usually they're not violent, but they can release huge amounts of lava. Believe it or not, we're done plate tectonics, done the chapter. Except we need to practice this, okay? Because, Taylor, this is very different from chemistry, very different from physics. You're going to have to memorize a lot more as opposed to apply a lot more. So what do I have for you? Your homework right now is from the textbook, that and that. I did include the answers so you can check your answers. Don't just copy. But I also got some pictures to show you. Pause.